Okay, good evening again. Now we'll discuss about redox reactions. Okay, so before that, just to remember CBSE last concept, first chapter, 10th class, chemical equation reaction. They given about oxidation and reduction reactions. Just remember here, they given about something called rancidity. So rancidity, nothing but what's food will be there. And food we have, I think fat will be there. There is a fat is undergoing oxidation. It is, and so that what happens, food will get spoiled and get a bad smell, even taste also. So that's why this process is called rancidity. Okay, rancidity means, remember, food is in the food, whatever fat things are there. Fat means generally we can say oil items are there. Oil things are there, they will undergo addition, means they will undergo the oxidation process. That's why we get a bad smell and taste. This process is called rancidity, and this kind of process is example for what's the oxidation. Sometimes in the examination they will ask, okay, give the example of oxidation process in your daily life. They will give the question that give the example of oxidation in your daily life. So can give example like rancidity. Even they can give one more example they given about corrosion. Okay, corrosion is nothing but what happens in corrosion. In corrosion, just remember here in corrosion, we know very well iron will be there. Iron is react with the atmospheric oxygen. The presence of moisture it forms Fe2O3 plus, it's not plus, you can say X number of, sorry. So it forms Fe2O3 dot X number of H2O. So here X is variable. Okay, why? Because it is X means here X number means moisture will be variable. X H2O represent moisture. Okay, the different it is differ with different phases. Okay, different, that's why we can take X as variable here. So anyway, iron oxide will be an which color? So this is a reddish brown color. Reddish brown color. This is also example for what process? Oxidation process. So in this both the cases, remember we are going to adding the what's that? Add the oxygen. So addition of oxygen is nothing but what's that? We can call as oxidation. Okay. Similarly, you can go on. They remember different metals are there. Even copper is going to react with carbon dioxide and moisture. And O2 it forms okay, it forms copper carbonate dot copper hydroxide. CuH taken. I think it will be in twice. This is a mixture of. This is green color. Generally, it is also called patina. Patina. This is another example for oxidation. Okay. So now, so after this one, we go for example of oxidation process. Means to discuss about oxidation. There is two processes are there: oxidation, and one more thing is called reduction. Okay. So what do you mean by oxidation? So addition of oxygen, or we can say a removal of hydrogen, or we can say a removal of electron. Okay. Similarly, increasing in charge. Okay. These are oxidation. Similarly, we can say now removal of oxygen, and similarly we can say addition of hydrogen. We can have addition of electrons. or we can say decreasing in charge. So these are the four important things we should understand. Addition of oxygen, removal of hydrogen or removal of electron or increasing in charge is called oxidation. Okay. Similarly, reduction means removal of oxygen and addition of hydrogen, addition of electron or we can say decreasing in the charge. Let's remember. Okay. Now discuss about reactions. We'll come to know. Okay. So to me there are some reactions are there. So let me write the reactions. First we have aluminium plus oxygen gives rise to Al2O3. Okay, now see here in this process we can say this aluminium undergone the oxidation process. So I can say aluminium oxidized oxidized towards oxidized to Al2O3. Okay, similarly, and what we can say, I can say oxygen. Here you can say operation state is here minus, sorry, this is minus 2, this will be on 0. So 0 to minus 2. So I'm saying again here this is minus. Okay, so we have, suppose I said that, suppose this, remember this one, this is 0, this is plus 1, this plus 2, and this will be plus 3, and this will be plus 4. Similarly here minus 1, this is minus 2, this is minus 3, this is minus 4 and so on. So you see as we are moving from left to right, we can say there is increasing in the charge, increasing in number, right? Increasing in charge, which is nothing but oxidation process. So similarly, if I am moving from right to left, we can say this is decreasing in charge. Okay, so I can say this will be an what? So this is an reduction process. Okay, this is called reduction process. Let's remember here zero charge is there. Beginning before reaction of oxygen have a zero charge. Now we got minus 2. So it will be an 0 to minus 2. So I can say oxidation undergoing which process? Reduction process. Similarly, you see if I take an aluminium 0 elementary form, it is in the form of plus 3. So 0 to plus 3, 0 to plus 3. I can say aluminum is undergoing this process of oxidation. So in this way we can find out oxidation and reduction. Some more reactions are there. We find the reaction. So SO2 plus O2 gives rise to SO3. SO2 plus O2 gives rise to SO3. So I can say here is an SO2. For this one they are adding O2. It forms SO3. So which substance? So you can see here. This is here we have minus 2 operation state and this will be an I think 2 are there. So minus 2 into 2 minus 4 will be an plus 4. So it is in the form of 0 and it will be an also here plus 6 and this will be an minus 2. So what I can say here, in this process sulfur is undergoing process sulfur dioxide. Sulfur dioxide is oxidized. Again it is what's oxidized towards oxidized to SO3. Remember, so again we are adding oxygen here. So now in this process you see here this oxygen, so it will be on 0 to minus 2, you know very well it is an decreasing in charge. So O2 is in 0 charge and it will be in the form of what, SO3. It is in minus 2, it will be on what we can say 0 to minus 2, we can say reduction. Okay, reduction because what's that? Because charge is decreased. So decreasing the charge is called what's that? Is called which process? Reduction process. Okay. Now one more example is that let us see the given one more example, that is so copper sulfate they taken copper copper sulfate plus potassium iodide gives rise to the given copper iodide plus I2 they given and they given K2SO4. Now it's just to find out here. This is SO4 minus 2. This will be 1 plus 2. This is plus 1. This will be minus 1. And this will be the 1 iodine is minus 1. Then it will be onwards plus 1. And similarly, the elementary form is 0. And it will be on K2 is plus 1. SO4 is minus 2. So now what I can say here. See here, iodine is there here to here. Okay, here what I can say elementary form is that. So minus 1 to 0. What I can say minus 1 to 0, I can say it is moving in that direction. You can say it is undergoing oxidation. So iodine is undergoing the oxidation process. Just remember. After similarly, you see a copper is there. So this copper is a copper. What is the condition copper, sir? Copper is converting copper plus 2 to copper plus 1. So what I can say, shall I say it is an decrease in the charge, right? So I can say it is decrease in the charge. I can say it will be an what's a reduction. Decrease in the charge as we discussed already. It is an example for what's a reduction. So in this case, what about potassium, sir? You see potassium is plus 1, here also it is plus 1. Similarly, SO4 say minus 2, here also you can say SO4 minus 2. We can't say particularly sulfur and oxygen, but as I'm saying, both are in the same condition, so I can say there is nothing change in their charges. That's why we can say they didn't undergo the oxidation reaction. And these kind of reactions are there. This kind of reactions means what kind of reactions are? One more example I will say for you people. Okay, now see they given one more example H2S. H2 it's for this one they're adding Cl2, it forms HCl plus sulfur. So here what I can say, sir, here you can see for plus 1 this will be on minus 2, this will be on a 0, this will be on plus 1, this is minus 1, this will be on a what's that? It is on 0. So what I can say, sir, Hc is minus 2 to 0, minus 2 to 0. So minus 2 to 0, what I can say, minus 2, minus 1, 0. It is moving in that direction. You can say it is undergoing oxidation. So this substance undergoing oxidation, sir, you can say H2S. Okay. What about this hydrogen? You see, hydrogen is plus. Here also hydrogen is plus. So what I can say no change here. In the case of hydrogen, hydrogen doesn't undergo the any of process. Now similarly, you see Cl2 is 0 form and it is in the form of Cl minus 1. So 0, this is minus 1, this is minus 1. Directions are direction decrease in the charge, right? So I can say this is undergoing reduction or you simply use here. So what we happens are here, here tier what I can say, here tier, you see here, removal of removal of what's that? Hydrogen. It's called as removal of hydrogen. Addition of oxygen or removal of hydrogen is called what's that? Oxidation. Correct? So I can say this is undergoing what's that? Oxidation. Similarly, here you see here to here I shall say addition of hydrogen. Addition of hydrogen means what's that? It is reduction. So we can by this all things we can come to know that there are certain things or definitions are there we should remember here. Okay. So I can say oxidation means what's our addition of I can say this is addition of addition of oxygen and removal of hydrogen or removal of electron or we can say increase in the charge is called what's a oxidation. Similarly, removal of oxygen, addition of hydrogen, addition of electron or decreasing the charge is called as a, so simply one more example I will say suppose if they given suppose if they given like this what kind of process here. So here one more example you can suppose we have here we have sodium, right? Sodium is a sodium becomes sodium plus 1 by losing one electron. So what kind of processor it is? You can see here a removal of what's the electron. Removal of electron is called what's the is called oxidation. So I can say sodium is undergoing oxidation process. Similarly, if I take an Cl gaining one electron from sodium becomes Cl minus 1. So I can say what's the addition of electron, you can say it will be which process? A reduction process. That's why if I take and combine together, I can say Na plus NCl minus becomes NaCl. Sorry, I can write here Na plus Cl gives rise to NaCl. So it will be plus 1, it will be minus 1, 0, 0. 0 to plus 1 which process are oxidation, 0 to minus 1 which process are reduction process. Okay. So by after knowing this reduction and oxidation process, there is something called a redox reaction. So what do you mean by redox reaction? Nothing but what's that? So chemical reaction, chemical reaction in which both oxidation as well as reduction will take place. Okay, what about this displacement reactions here? Copper sulfate is there. We added Fe and it becomes what's that? FeSO4 plus copper. What kind of reactions are this here? Copper is here plus 2, this is minus 2, this is 0. This is what sir? This is plus 2 because this is minus 2, this is 0. I can say here to here what I can say sir. So increase in the charge rate, I can say it is an oxidation. Here to here is here to here. So minus plus 2 to 0 again I can say reduction. So both processes taking place in the reaction. That's why these kind of reactions are called redox reaction. Okay, similarly you can take one more example. So they given textbook what they given sir? They given I think MnCl2 plus H2 gives rise to not MnCl2 sorry some other reaction I think so. So what we should this one? They given I think Mn MnO2 correct? MnO2 plus HCl gives rise to MnCl2 plus Cl2 plus H2. Think so. This is the reaction given here. So I can say this will be a not here minus 2, 2 are there. This is minus 2, here minus 2 into 2, minus 4, it will be an plus 4. We can say it will be an plus 1, this is minus 1. You see here 2 Cl are there, minus 1 into 2, 2 are there, that's what is a plus 2. If this is elementary form 0, it will be an plus 1, this will be an minus 2. So here what I can say manganese undergoing which process decreasing in charge or increasing in charge. Decreasing in charge we can say reduction. Similarly, mm, decreasing in charge correct? Correct. Okay. Decreasing. Similarly, you can see this chlorine. Where chlorine is minus one. So minus one to chlorine 0. So what kind of we can say minus 1 to 0? It is called as what's oxidation. Similarly, you see hydrogen is same only. Hydrogen is positive, they are also positive only. O is minus 2, it also O is minus 2 only. No change. So I can say, so I can write as MnO2 reduced. MnO2 reduced towards MnCl2. Similarly, I can write as HCl oxidized. HCl oxidized towards oxidized to Cl2. Remember, okay. So these kind of things will be there. Be carefully should see the equation then where to where. And one more common mistake done by every student is they are going to identify individual elements. So, but in the examination, they are not asking about individual elements. Remember, suppose what I'm saying here. Suppose PbO plus carbon gives rise to Pb plus CO. Okay. Now see, here to here we know very well. Here to here there is an what's a oxidation. Here to here what will be said? There is an what's a reduction. So here you remember here. Here which substance is undergoing reduction, sir? Lead or lead oxide? Answer is lead oxide. Similarly, you see carbon is undergoing what's that? Carbon becomes carbon monoxide. So I can say carbon is oxidizing, not carbon monoxide. So you can read the statement. First question MCQs they given. Okay, lead oxide reduced. Lead oxide reduces towards that lead. This is important. Not lead reduces to something else. Okay. So similarly, carbon oxidized towards a carbon monoxide. Okay, Divans, once you listen carefully, again, see, here you see, they given the equation. So we have equation MnO2 plus they given I think HCl, right? HCl gives rise to MnCl2 plus thing Cl2 plus H2. So once we verify this equation whether it is correct or not. Here, if we take an Mn here, so first we should know here. See from here to here, normally we can say our definition also we have. What definition we have, sir? We have definition with respect to the oxygen. What about removal of oxygen, sir? Removal of oxygen. What we can say? We can say we defined as what's the reduction process. So in that way also I can say here to here there is an what process? A reduction process. Okay, here to here MnO2 to I can say MnO2 reduced reduction. That's why it is reduced to water, reduced to MnCl2. This is one method I'm saying. Similarly, you see from here to here. Here to here we have one more process called removal of removal of hydrogen. What is the name, sir? Removal of hydrogen we defined as what? Oxidation. So in this way also I can say from here to here there is an reduction. In here to here I can say there will be an oxidation. So you don't want what you don't want risk processor. So normally what happens here? Just you see the equation again one more time I'm writing here. MnO2 plus HCl, okay, gives rise to MnCl2 plus Cl2 plus H2O. So here you should know about something called oxidation number means charge. So particular compound in particular compound, different elements have different oxidation state. See, normally this oxygen will show -2 as oxidation state and two oxygens are. That's why -2 into 2 will take -4. If it is -4, it should be on what's that +4 because total sum of the all charges should be equal to 0 in the molecule. So it is called molecule. If not is equal to 0, it is called ion. Okay. Similarly, you see here hydrogen is +1 and Cl is -1. Both are cancelled. So final charge should be 0 in the molecule. So it is called molecule. If not, it is called what? Ion. You see here 2 Cl are -1 into 2 will be -2. It should be an what, sir? +2. You see Cl elementary form is 0. Remember, oxidation state of any atom in elementary form is 0. So it is +1, two hydrogens are there, 2 into +1, it will be an -2. Now you see here from here to here. Mn here what is charge are here the compound this compound I am saying. Better I will write here just a second, okay. Now see in this case you see I'm taking here MnO2 and it is converting into what's the MnCl2. So you got already in MnO2 Mn charge is what's that will be an +4 and what about here, sir? It will be an Mn +2. So charge, what is the charge are here? Charge is decreasing or increasing. You can say +4 to what's sir +2 is decreasing in the charge. Also called what's sir reduction. Okay. Similarly, you take one more HCl is that HCl2 Cl2. So we can say here what's our equivalent? Cl charge is -1. Here in the form of what I said, sir, Cl2 means it will be an 0. So we can say -1 to 0. The charge is what we can say is increasing. That's why it is called what's our oxidation. Clear? In this way also we can explain this process. So should know about something called oxidation number and how to find oxidation number. I will say small things here. Suppose if we have we don't know about this all oxidation number and all. Generally it will be not applicable. You should know some oxidation numbers also. You see, suppose here we have a yes we can take Km for potassium permanganate. So at least you should know what is the oxidation state of manganese here. Take it as X. How many potassiums are there? One potassium. What is the charge generally potassium will possess? Potassium have K shell 2, L shell 8, M shell 8, and n shell 1. So it want to lose. K always want to lose one electron. It will form K plus by losing electron. Similarly, oxygen you see K shell having 2 electron, L shell having 6 electron. It want the 2 electron. That's why oxygen always want to gain 2 electron, forms O minus 2. General line speaking. Again we have oxidation state, different oxidation state. So here see, here how many potassiums are there? 1 potassium, that's why 1 into plus 1 I am taking. Here plus 1 we got here. Okay, plus Mn take it as x only, 1 Mn, that's why 1x I am taking. Plus 4 oxygens are there, or the oxidation rate of oxygens are here minus 2. So it will be plus 1 plus x minus 2 is equal to 0 should take, is equal to 0, or we can say x minus 2 is equal to, that side no, sending this side is minus 1, x is equal to, we can say as, something went wrong, right? Wait. Here you see, I forgot, here I forgot something that I did math wrong here. Let's see. Now see here. So here we taken as 1 plus 1 plus 1x is a 1x plus here 4 into minus 2. So you can take as 1 plus x minus 4 to the 8 is equal to 0. So 1 plus x is equal to, this side I am sending here, it becomes positive 8 plus 8, x is equal to plus 8 minus 1. It will become x is equal to what's that? Plus 7. If you know this way, then one more component will get right side, then you should compare with those things. Okay. Still anybody have doubt regarding this concept, please ask me so that I can clarify the doubts. So now we can move to the blue questions. Okay. So let's select like this file better. See here, already we discussed remaining blue questions. So this is the equations they given here. I hope so everyone, let me write this equation better. Okay. So they given here where you have mixed in solution of lead nitrate and potassium on it. What was the color of precipitate? So already written, I think this. So already, okay, written here. Lead nitrate. What is the formula of lead nitrate, sir? So lead nitrate formula is very well. So let me write here. PbNO3. Okay, taken twice. And potassium iodide is Ki gives rise to lead iodide, which is PbI, which is an yellow color PPT. Okay, plus we'll get potassium nitrate, and this kind of reaction is called, very well, it's called precipitation reaction. Okay, so and after write the balance chemical equation for this reaction. This is a double, yes, this is double displacement only. So under double displacement reaction, again based on what's that, based on products. So if suppose product is insoluble solid, then it is called, what's it is called, precipitation reaction. Suppose products are salt and water, and what it is called, sir? Salt and water. It is called neutralization reaction. Okay, just remember. Now next questions we can see. Shubham Chahal. Tell me, sir. Saying hello. Star voice test. Okay. Hmm. Now see next and after we have still more some other questions are there. Where magnesium burns, we call activity. This one activity they are asking. Okay. Now see here, there are some more something they are saying here, where the magnesium ribbon burns with a dazzling flame in the air and changes into the white substance, magnesium oxide. The magnesium being oxidized or reduced. So what is the answer? So here definitely we can say magnesium plus O2 gives rise to magnesium oxide. So I can say magnesium, what happens at magnesium to magnesium plus 2 over here. Okay. 0 to plus 2. What I can say increasing in the charge, right? So I can say it is undergone the oxidation process. Next. So then after come to this blue questions actually. Aqueous solution of copper sulfate and we added iron nail. So iron is more reactive than the copper. So iron sulfate plus copper is formed. So this color FeSO4 color is what sir? Green color. So it is indicating that formation of FeSO4. That's why color is going to change. Because of what kind of reaction this is sir? More reactive metal displacing less reactive metal. It is called displacement reaction. Displacement reaction. Okay, now see next give the example of double displacement reaction other than the given activity 1.10. So can you write KBr plus AgNO3 gives rise to, so KNO3 plus AgBr. I think this, see here also see positive, negative, positive, negative, again positive, positive exchange over here. In the place of Ag we got potassium, in the place of potassium we got Ag. This is also double displacement reaction. Identify substance which are undergone the, what's that? Which are undergone. So they given here, they're asking you people to identify the process of oxidation and reduce. So we can say that I can take example here. Na becomes what are Na plus in the first process. That's why it is increase in the charge. So I can say it will be an oxidation. So if you see, can see here Na plus O2, O2 gives rise to Na2O. So I can say this is yes, zero charge here. This is also zero. Here plus 1, this will be minus 2. So 0, 2 plus 1, this is increasing in the charge. That's why I can say it is undergone oxidation here. 0 to minus 2 is, I can say 0 to O minus 2. I can say it will be an decreasing in charge is called reduction process. Similarly, you see this one more example to given. One more example I'm writing here. So Cu plus, sorry, they given CuO. Okay, this is not Cu. So CuO plus H2 gives rise to Cu plus H2O. So you can see here to here what happened again, here to here. You can say removal of oxygen is called reduction. Similarly here to here you see addition of oxygen is called also oxidation. So in this way you can understand this concept that we discuss about these questions actually. So what is the first answer? So which of the following statements about reactions and below are incorrect? Incorrect they're asking. Underline this word incorrect. They're asking incorrect, not correct. Lead is getting reduced. Lead is getting reduced or lead oxide. So we can say lead oxide. That's why the statement is a wrong statement. Okay. Carbon dioxide is getting reduced. Carbon is oxidized into carbon dioxide. This statement is wrong. Carbon is getting oxidized. Yes, correct only. C is become CO2. That's why lead oxide is getting correct only. So correct statement are C and D. Wrong statement are A and B. This is right answer. Next you see. Uh, next Fe2O3 can see here. So you know very well this is aluminium. This will be the iron which is more reactive. You know very well. Al is more reactive than Fe. I can say Al is replacing or displacing. That's what reaction is called. What kind of reaction it is? It is example for displacement reaction. Right? The what happens? Dilute hydrochloric acid is added to the iron filings. So add Cl plus Fe we are adding, then what happens are either FeCl2 or FeCl3 will produce and hydrogen gas is produced. So hydrogen gas and iron chloride is from correct only. Chlorine gas and chlorine gas is not common here. No reactions taken place. No reactions taking place. Iron salt and iron salt and water not is water not hydrogen gas is produced there. So what is the balance equations? Chemical equation. Why should balance chemical equations? What is the answer, sir? I can say here mass of reactants will be equal to what, sir? Mass of product. This is called balance. Why you should balance it? Because 2 by LCM means what, sir? Law of conservation of mass. Translate the following statement. Translate the following. Hydrogen gas combined with nitrogen gas forms ammonia. So they are saying that hydrogen gas combined with nitrogen gas. Hydrogen gas combined with hydrogen gas is H2 plus combined with the N2 it forms 2HN3 NH3. Okay, this is formula of ammonia. Okay, so it should balance. I am writing again H2 plus N2 gives rise to NH3. We balance three hydrogens are two are there, should multiply with two here. So not two, you can write multiply with three here. So balancing right here two is balanced now. It is balanced chemical equation. Now next question you see. Next question. What is next question, sir? Hydrogen sulfide gas burns in air and produce water and sulfur dioxide. Hydrogen sulfide burns in air, sulfur dioxide. Hydrogen sulfide formula what, sir? This formula is hydrogen sulfide formula is H2S. Plus burns in air, they are saying producing what's a sulfur dioxide plus what's a plus water. Sulfur dioxide they are saying here. So balance it H2S plus O2 plus O2 plus H2O. Okay. How many hydrogens? Two hydrogens, and how many sulfur? One sulfur. Oxygen three atoms. So even and odd number. I said multiply with question two. With two H2S plus O2 gives rise to 2SO2 plus 2H2O. Okay. So now how many hydrogens? Four hydrogens are there. Four, 2 into 2, 4 are there. 2 into 2, 4 are there. 2 into sulfur, 2 sulfur, 2 sulfurs are there. Now see oxygen, how many are there? 2 into 2. 2 into 2, how many? 4. So 2 into 1, how many? 2 plus 2 is equal to 6 are there. 3, 3. So it will balance 2. Okay. So can balance in this way. Now see some other questions are there. Barium chloride react with aluminum sulfate. And asking sulfate gives aluminum chloride and precipitate barium sulfate. Barium chloride, aluminum sulfate. So barium chloride formula is what's that? BaSO4, right? Barium chloride formula is what's that? BaCl2. Okay. Aluminum sulfate AlSO4. So is 2 and SO3 is 3. Gives rise to double displacement reaction. Barium will come in the place of aluminum, aluminum will come in the place of barium. So what will get here? Okay. So let's say here, I'll write here aluminum chloride AlCl3 plus barium sulfate BaSO4. So this BaSO4 is insoluble solid. This is called precipitate. This reaction is called precipitation reaction. Now see one more next question is potassium metal reacted with water. Potassium to the water it seems. Okay. So you can say potassium plus water. So K plus H2 gives rise to potassium hydroxide KOH plus hydrogen gases produced here. Should balance right here. I forgot to balance. I think barium, how many barium? One barium, one barium. No issues. Two chlorines are there. Three are there. Multiply with two and multiply with three. So three bariums are there. Multiply with three. Okay. So three barium, three to the six chlorines are there. Two into three, six are there. Okay. Two aluminiums are two aluminum super. SO for three and three SO for balance. Now see here. Two potassiums are there. So one potassium, two hydrogen, three hydrogen. So multiply with two, right? So we get here two. So two to the four are there. So two to the four it becomes correct. One two potassium, right? This is now balanced. Two oxygen is balanced one. Okay. Now see remaining how many questions are there. Okay. Then chemical equation balance potassium chemical equations are balanced here only. Two hydrogen, how many nitrogens are there here? Hydrogens, one nitrogen, two are there. Nitrate, how many two are there? Multiply with two here. Okay, two. It is become two. Two calcium, two nitrate, two hydrogens are there. Four balanced, I think. So should write here two here. Okay. So two hydrogens are there, two into hydrogens and two into hydrogen, four are there, two to the four are there. So two into nitrates, two other get one. So how many calcium, one calcium is balanced. Okay, so how many oxygens are there here? See two, three, how many six are there? Plus here two are there, six plus two, eight are there. This side two, three, six are there, plus two, it's balanced. Okay. Now come to the calcium, hydrogens, how many are there? Balanced. NaOH plus H2. I think here two Na are there, two Na is balanced. Sulfate, how many? One sulfate, one sulfate, one OH, one OH balanced. Okay. So remaining we will discuss afterwards better, I think so. Okay, good night.